remind you about the Bernoulli equation. Okay? The Bernoulli equation is just a differential equation which has the general form writing as this equation dy by dx plus 3xy equal to 2x times y to the power n. And n could be any number. It can be positive, can be negative, but n should be equal to 1 or 0. Okay. Like I said, n could be any number except 1 and 0. Can be negative, can be fraction. Now, the last problem that I got to you, n is equal to 3. But with this problem, if you look at the problem statement itself, you will find that n is equal to what? Negative is a negative number, right? And it is a fraction which is equal to 1 over 2, right? Negative 1 over 2. So if you write it another way, you can get something like this. So the way to solve for the solution of this problem, you should make the coefficient in front of term differentiation to be 1 first. Okay, because any time, as you see from this equation, we derive the way to find the solution of this equation based on this general form. And this general form, you have the coefficient in front of the dy by dx equal to 1. So you should do it before you do any assumption. Because sometimes you might see y term in front of dy by dx. If you don't make it into 1, then you will be in trouble because you couldn't be able to define what should be n. Okay? So in this case, the way that I do it first is just that making the coefficient of the dy by dx equal to 1. So that means I just multiply the whole equation with 2 over 3. Then I would get dy by time by 2 over 3. Okay. Okay, and then since we already know that this is the Bernoulli equation, so the way that we solve for this type of equation is just that we assume v is equal to y to the power 1 minus n, right? And our n is equal to negative 1 over 2, so we got y equal to 1 plus 1 over 2, which is y to the power 3 over 2. And then, like, we try to change the term dy by dx into the term dv by dx. So what we do next is just that we do differentiate of v to the x. Okay? So we found that dv by dx is equal to 3 over 2 y to the power 1 over 2 dy by dx. And then we write it in the term of dy by dx equal to 2 over 3 y to the power minus 1 over 2 dv by dx. Okay? Let me put this as equation 1, and here is 2, and there is 3. Then we put 3 into 1. Okay? We will get 2 over 3 y to the power negative 1 over 2 dv by dx minus 4 over 3x times y equal to 2 over 3x squared exponential of xy to the power negative 1 over 2. And then again, we just make the coefficients of dv by dx equal to 1. So we would get dv by dx minus what? So it is 2 y to the power 3 over 2 equal to x squared exponential of x. Is then equation 4. When you look at the equation 4, now we have dv by dx, and we have x as the dependent variable. So we need to change y to the power 3 over 2 to be v, which is our equation 2. So we put equation 2 into 4. Okay, so we get dv by dx minus 2v equal to x squared exponential of x, equation 5. Now equation 5 is just turned to be linear differential equation. So now if you want to find a solution, we just use the technique of the linear differential equation. And that way we get to find what? Integrating factor. Right? Now the coefficient in front of dv by dx equal to 1 already. So now our px is negative 2, right? And our qx is x squared times exponential of x. So from this we can find the integrating factor. That we use mu, right? Equal to e exponential of integral px dx, which is equal to, let me put right here, our px is equal to negative 2 and our qx equal to x squared times exponential of x, right? Now we get what? Exponential of integral negative 2 dx, which is equal to negative 2x, right? When you do integral of this term, you would get, let me put it the simple way, 2, negative 2 is a constant, so you can take it out from the integral sign. So you have only integral dx. Integral dx equal to x. So we would get the integrating factor is equal to exponential of minus 2x. Do you know what I missed? I missed this x there. Sorry. Now it's to negative 2x. This is over x, which is equal to ln x. Okay? So our integrating factor is what? Mu is equal to what? Exponential of ln x to the power negative 2, which is equal to 1 over x squared. Okay, so as I said, from the linear differential equation, you know that v is equal to 1 over integrating factor times the integral term of integrating factor times qx dx plus c. Now you know that your mu or integrating factor is equal to 1 over x squared. You just plug it in there, you would get x squared. And inside there, 1 over x squared times qx is equal to x squared times exponential of x. Just like that. And then you see x squared there and x squared there, they all cancel out. So inside you have only integral exponential of x dx, which is equal to exponential of x, right? Is this the answer? Is it yet? Now this v there, do we know v from our problem statement? Do we know v? We just assumed it, right? So now the last step that you got to do is just return v back to y. So v is equal to y to the power 302. That's the end.